Good afternoon, and welcome to Ohio Arts Council's monthly webinar. I have the chat window open, so just in case someone can't hear very well or anything like that, just send me a quick chat message and we'll make adjustments. Today, we'll be talking about data analytics and data visualization. The first step to uncovering what your data can show you and tell you and your constituents is to locate your data and get it into a usable form. And sometimes that's easier said than done. Luckily, most of us have the possibility of accessing at least one data source, website data. Everyone on this call should have a website. If you don't, purchase a domain name for yourself or your organization and build a simple site on one of the many low-cost or free platforms out there. If you would like this topic covered as a webinar, please leave a note in the comments and I'll schedule one. The website data can be captured using a number of different tools, but the most popular, however, is Google Analytics. So here is the administration page for the Ohio Arts Council's Google Analytics account. Near the top of the page, you will see our tracking ID number. That's under the blue circle. This is unique to every Google Analytics account. Some content management systems have a cut and paste method of putting this tracking ID onto your website, while others require you to copy and paste the code snippet that's in the red circle onto your master page template. The tracking ID and/or code needs to be on every page within your website in order to send Google the necessary information about who's using your website, how they arrived, what pages they're clicking on, when they leave your site. And each website visitor leaves a trail of information when they visit your site. Geographic information, demographic information, time usage, page clicks, frequency of site visit. You get the idea. So Google Analytics has some very nice built-in charts and visualization tools for you to understanding your data. And for some people, this is the only visualization tool you'll really need. But for others, this data would be more helpful if it were compared with some other data that your organization produces, things like ticket sales or grant funding or member directories. You get the idea. So data analytics software is the answer for those mashup ideas. So first you need to export Google Analytics data to a file you can use in data analytics software. Here, I've navigated to the behavior section of Google Analytics and selected site content and then all pages. And once on this page, I've created a secondary dimension of city. To do this, I clicked on the secondary dimension button and selected users and then selected city. Scrolling back up, I changed the report to reflect the grant awarding time frame here at the Ohio Arts Council, and then limit the pages we're looking at to only include the grants pages. And finally, expand the number of results to the maximum for downloading. Then I'll download an Excel spreadsheet containing the data. Let me quickly exit PowerPoint and show you exactly how to do this. So here, my page is loading. Like I said before, I'll navigate to the behavior section of Google Analytics, click on site content, and then all pages. Then I'm going to create a secondary dimension of city by clicking on users and then scrolling down to city. At the top of the page, I'll change the date range bottom of the page, I'll change how many rows to display to the maximum so that we can download the most data possible. So we'll take just a and then here, I'll limit what we're looking at to just the grants page on OAC's website. And then the final step, I'll navigate to the top of the page once again and click the Export button and click Excel. And now this downloads an Excel file to my computer. So going back to my presentation, this is what the Excel file looks like coming out of Google Analytics after I've put together all of those specifications. So here we have page, which is the same for every row. It's the grants page because that's the page we're interested in looking at. And city, each city has its own row. And then page views, these are the pages viewed within a session, and where a session is when one unique IP address during a certain time frame clicks on one or more pages. Then the next column over is unique pages. Unique pages is the number of pages counted only once per session. And then we have average time on page, and that's in seconds. And we have entrance, which is the number of users whose first page in their session was the grants page. We have the bounce rate, which is the number of users whose first page was the grants page and who left after seeing just that page. And then the next we have the percentage of exits, which is the number of users whose last page in their session was the grants page. And then the last column we have page value, which is not set, but we could have a number value for how much traffic to this page is worth our marketing efforts or different measuring tools that we want to put in place. So that's Google Analytics spreadsheet. But like I said, what we're going to do is we want to mash this up with some other data. So I've also downloaded a spreadsheet from Arty, which is our smart, simple platform for managing grants. And here we have application number, which is unique to each application, each grant application. We have funding program, which is the name of the program each grant was connected to. We have organization, which is the name of the organization receiving the grant. We have project title, which is the name of the project that got funded. We have amount, the amount of each grant, obviously. Then we have address, and status is, for all of these, it's going to be awarded. And then city, state, and zip is pretty self-explanatory. So you can see, if we combine all of the projects that were funded by the OAC to who accessed our website during that same time frame, we could look for a correlation between accessing the site and an increase in funding for organizations. We'll be able to see if smaller cities receiving a small amount of money and a larger than normal number of site visits. This could mean that the site might be optimized for better access. There'll be a number of things that we'll be able to uncover by looking at this data along with our website data. So now it's time to select a digital analytics visualization tool. Each one has its benefits, and all of these are fairly easy to use. I use Tableau primarily because it was the first one I encountered. The enterprise version was available for staff at my former job. So Tableau has a free version that is almost exactly the same as the one I'll use today. The real difference is are between the free and the paid are the ability to connect to a wider range of data sources and the ability in the paid version to save packaged files for distribution. Google Data Studio and R are both free, and Trifacta is a product out of Stanford University and offers a slimmed-down free version. Power BI, or Power Business Intelligence, is a Microsoft application, so that one may feel familiar to folks who do a lot of work in Excel. And lastly, Plotly, which is very similar to Google Data Studio. It's entirely web-based. They have a free version and a paid version as well. I'm not going to go into any of these except Excel because they're really very similar when it gets down to the brass tacks of what type of data visualizations you can do with each. So here is the public website for my version of Tableau. The application seamlessly publishes your workbooks and dashboards to the web for sharing or embedding onto your own website. So when you've actually put something up as a dashboard or you finished working on it, you can publish to your personal website and then either point your audience to the dashboard site itself, like what you're seeing here, or by clicking on any one of those visualizations, you can then get the code that shares those visualizations onto your own website. So at this point, I'm going to exit PowerPoint again and take you directly to my Tableau workbook for this webinar. The examples I'll be using are designed to be easy to understand. The one thing you might want to take away from this is that no matter how clean you think your data is, there's usually something in the data that will mess up a calculation or a visualization. And if this is happening to you, you've got to go back to Excel and view your data and look for out-of-aligned columns or incorrect data in a row. It takes a while to massage your data to get into a spot where it's entirely usable, even if it's coming from a reputable source like Google Analytics. So just a second, and I will open up Tableau. Okay, so here we have Tableau. The first screen I'm going to show you is the data source screen. When you open up a new project, this is the first screen you'll deal with because this is how you get your data into Tableau. Remember, we're working from 2 Excel spreadsheets. The screen imports and connects the Excel files we saved earlier. So grants 18 up here is the RD Excel export, and analytics is the Google Analytics export. And within each one of these Excel files, there are also worksheets. And so switching back and forth between these, you can see that these worksheets down here change. So you have the Excel connection, and then below you have the sheets themselves. Here, in our connections pane, we have connected sheet 1 from the grants Excel file to dataset 1 in the analytics Excel file. And clicking on this inner join, the join section of the connections pane, we can see that we're joining these 2 data sets by city name. And below that, we can actually see the data itself, or at least some of the data, a sample of the data. And we can see that it starts out with the Google Analytics data underneath the orange section, and it moves to the RD data in the blue section, and the city names line up. Pardon. So moving on to our first worksheet, the tabs down here in the bottom are how you navigate between data source, worksheet, and dashboards. And you can also create another higher level of organization called a story. Right now we're going to just deal with worksheets and dashboards. Our first worksheet is going to be a simple table. It's going to be just to present the data with a few different ways to sort and search the data. So starting at the top of the worksheet, we have columns and rows. Columns and rows. And to the left, we have our data separated into dimensions and measures, and down at the bottom, parameters. Tableau automatically assigns either a dimension or a measure to all of your data fields. So dimensions are data that contain discrete categorical information. So city name, state, zip code, address. Measures are quantitative or numeric information, things like unique page views, amount awarded. In the worksheet, I've placed funding program, organization, and city in the rows and nothing in the columns. The marks section of Tableau is what displays when either you hover over one of these numbers. You can see this by clicking the tooltip, and these can be edited. In the marks section, I've added all of these things that are in the rows, and also the amount awarded, and I have color for search. I've placed city in the filters section so that it will appear on the side here, and I've changed the value. I've changed the value to multiple values drop down, and I'll show you why I did that. It makes it more usable to sort later. So I have all selected now. If I select none, everything disappears. And if I wanted to view the big 3 C cities, I could just limit it to Columbus, Cleveland, and Cincinnati. And it dynamically refreshes that data. So immediately you can start to see the power of even just putting your data into a visualization tool and creating something just as simple as a table format. In addition to the city filter, I decided I wanted a free text filter as well. I created a parameter which then also connects to a dimension and creates over here a free text search. So if I wanted to search on just schools, I'd be left with just organizations that have schools in the name. Moving on to the next tab, we have Map. At the top, you'll see that in the columns section, we have longitude, and in the rows section, we have latitude. This is automatically generated by Tableau from the Excel data when it detects that there is address or geolocation information in your data. So automatically it will create a latitude and longitude for your data set. And so up here, I can select different types of maps. My preference here is the Tableau default map, but you can have different map services associated with your Tableau application. You'll see that I've also added page to the rows column. And page is just the fact that every single data element we're looking at here today is oac.ohio.gov/grants. So by doing that, every single dot on here represents a geolocation that is picked up by our Google Analytics data and then mashed up with our grants funding. In the marks section, I've added, in addition to city and state, I've also added unique page views, number of grants awarded, the amount awarded, and then I created two calculated fields, number of grants per page view and dollars per page view. So I thought that it would be interesting to see how many grant dollars went out versus the number of page views. So some of these will have an extremely high connection to the number of page views. So if there's 32 unique page views and $9,800 in grants, that's $111 per page view. Not that it can be a direct correlation, but it's an interesting data point to see the diversity of that page view to grant dollar in each geolocation. I can show you the math behind that, dollars per page view. This is a calculation that I did just on the fly. It's just dividing amount awarded by page views. So amount awarded is here, and I divided it by page views here. And then I can use that anywhere in my data. I added unique page views to the marks section and then assigned it to size. So the bigger the dot, the more unique page views that geolocation had. I added the dollar amount awarded to the color tab in the marks section so that over here you can see that the lower level funding is slighted towards red and the higher funded areas are slighted toward blue. And this will be a little bit more interesting once we get into the dashboard. Right here, it's hard to see the smaller dots, but when we filter out some of the other information, that'll become a little bit more interesting to look at. I've also added the state here in order to filter out hits from other parts of the country and other parts of the world so that we're only looking at Ohio data. I mentioned before that the tooltip appears when we hover over one of the data points, and that this tooltip can actually access any number of data points that you have sitting in your data set off to the side, dimensions and measures. So any of these can be pulled and used. So if you wanted to have, let's say, the workbook name, you could have the workbook name appear on this data set. Next over, let me make sure I have this. We have the chart worksheet. I decided to create a donut chart just to add a little visual element to my dashboard, which will be the final sheet that I show you. You do this by placing two pie charts together. So there's really two pie charts happening here. One is a little bit smaller than the other, and it's all white. And so it gives the effect of a donut chart. So it's I think it's a little bit more appealing than a pie chart. It looks a little bit more sophisticated, and I think it's a little easier to read. But that's the trick there, is to put two pie charts together and have one of them be slightly smaller and they have the exact same data together. And that's a little trick that you can do in any one of these analytics programs. On this chart I have, it's by the average number of records is the rows, and then here we have most of the data that's in our measures appearing, but we have the funding program and amount awarded displaying as the tooltip. The colors are associated by funding program, and the size here is just based on a size that I set so that one pie chart would be smaller than the other. Finally, moving to our dashboard and putting it all together. This dashboard can be shared on the Tableau site or embedded into a website, or if you have the paid version, you can download a standalone application that will work as a desktop application for someone in your office or whoever you share it with. So putting all of this together, I brought in all three sheets that I created, along with all of the ways that we have to sort, and then I've also assigned each one of these ways to sort to all of the visualizations, so that if I go in here and say I just want to look at I want to look at everything except Cincinnati, Cleveland, and Columbus, not Coshocton. And you'll see how the map has changed in color quite a bit. This way we can see that, Akron jumps out a whole lot more, Toledo jumps out a whole lot more, Bowling Green. We can scroll through the list of organizations and funded programs. We can also come over here and do that same free text search. And see all the different school programs. Scrolling down, we can see that the donut chart changed, and we're only displaying school information within the donut chart now. And then over here we have the detailed information that there are 2 grants awarded. Now some of this won't adjust based on the new information, because we're looking at data that changed. So Columbus went from quite a few unique page views down than it normally would have. And this is where the example falls apart a little bit, and this is an example dashboard, and there's a little bit more work that needs to happen here, but it's not proven that this traffic came from these organizations, I guess is the easiest way to say that. There's a couple of other steps I would need to do, but this is, for demonstration purposes mostly. So looking over at, let's sort this again. There's Cincinnati, Cleveland, Columbus, the big 3. So looking at Akron, we can see that there are 6,216 unique page views that came from Akron, from all of the organizations that are in Akron. created 24 grants, and that's $345,768. The number of grants per page view is a small fraction, but the dollars per page view, the funding is $18.56 per page view. Whereas in Toledo, their unique page views are a little bit less. Their number of funded grants are a little bit less, but their amount awarded is quite a bit more. And so their dollar per page view ends up becoming $44. Now, whether or not this is a relevant way to work, to look at this data set and whether it would be useful to someone in administration is to be determined, but this, again, is for demonstration purposes and to show you exactly how you can mash up the data. So I've got a number of questions here, and I thought, let me exit back out to here and answer some of these questions. Just give me a second to stay organized. So the first question is, why is the first step to create a website if not for marketing purposes? Would be addressing data analytics outside of web page use. So I feel like I did answer that. Let me know if I didn't answer that. What I was doing is web page use and the institutional data that we generated through our grants platform. So the next question down is, does each Excel file require a same unique identifier? And yes, that's a really important point, that there has to be something within both Excel files. So I was relying on city, but both Excel files have to have something in common in order to mash them up. Otherwise, there's nothing to associate one to the other. A lot of times, geographic information is pretty easy to associate, and so that's a lot of times that's what we end up using. Congressional district, zip code, county is really popular way to mash up this data, but there has got to be something that's the same in both data Excel files in order to combine them. The next one down says, if you use cities, do you need to make sure city in each sheet is the same spelling? Yes. If the same, so that's another thing about checking your data source, that if you end up doing a calculation you think is supposed to go one way and it ends up going another way in Tableau, there's a possibility that maybe one city is lowercase and the other city is uppercase and they didn't make the connection. And actually, when you combine Excel files in Tableau, it will spit out an error report and tell you which one of your rows or how many rows did not end up finding a match with the other data source. So you have a master data source, which is the Excel file you imported first. And then you have your dependent data source, which is the Excel file you imported second. And the dependent data source has got to match to the primary. And if it doesn't, if every single row doesn't find a home, then it'll throw off errors. The next question is, you said earlier you need at least 2 data sources. That's not true. You do not need 2 data sources. I could have done this entire thing just using RD data or just using website data. I could have stayed away from mashing up data from each one and just visualized information that was coming from one. So the next question down is, do you feel Tableau is a better tool than Power Pivot? I've never used Power Pivot, so I don't know what that is. But like I said, I think that a lot of these tools are very similar, and you know, it's more about preference and about what's easier to use for you than I don't think one is better than another. They're all so similar. They do very similar things. They all have mapping capabilities. They all do pie charts. They all do line graphs. They all do tables. They can all do searching and sorting. They all can import various types of data. I think those are all the questions. I know I went through that pretty quickly, but I wanted to make sure that I didn't present too much information so that it was overwhelming. I think that to get started with any of these tools, the first thing you should do is figure out, are there two data sources that you have that could be imported into an analytics tool, and find those data sources and find those Excel files and compare them and see if there's something between the two of them that could be used as a unique identifier for combining the two data sources. And if not, maybe just take one data source and try it out and see if you can come up with some insights just using one data source. You know, like I said, you don't have to have two data sources. Download one of these tools and try it out. And I think that's the best way to start with it. So the next question down, one of the ways that I started, so the question is, for someone new to data analytics, is there a good resource or where to start? I use lynda.com quite a bit, but there's also a ton of free resources on the web, and Tableau has an incredible, it's been around quite a while, and it has a great user base for sharing information. I also use a website called analytics-tuts.com, that's T-U-T-S, which I will type into the comments section. So that's in the comments section now. I use that quite a bit too, and also lynda.com, which is a subscription-based video learning platform, but it's extremely helpful to get started with this kind of stuff. The other thing is actually just downloading one or two pieces of data and getting Tableau and trying to just at least build that table view that I showed you before, and then trying to get to be able to sort on that table view, that table worksheet. When you can get to that point, a lot will open up for you, because you'll start to notice how the data is working together, how when you do a certain action within the worksheet, other things that fall in place, things like that. So I think that that's the best way to ease yourself in with that kind of data. Anytime you can use data that is over a period of time is also another good way to work, because using a line graph or some type of graph like that is fairly easy to construct. It's a lot easier to construct than some of the other ones out there, and showing something over time, increase, decrease, that sort of thing, is pretty easy for people to understand. So that's a relationship that, it's very visual. It goes up, it goes down. So change over time is a good thing to try to show when you're first getting started. So I think that is, those are all of the questions that I fielded. So thanks a lot for listening in today. And if you have any suggestions for future topics, feel free to suggest them, and we will schedule. Thanks again, and have a great afternoon.